Okay, so moving on to CAMEO Chemicals. Hopefully they all work. I just downloaded the latest versions of these. For whatever reason, my current versions, when I clicked help and like if you click the help tab and it says check for updates, it wouldn't do that. So to update them, I had to take them off my computer and then reinstall them. So not sure what's going on there. Kind of finicky, but we got it to work. So when you first open up Cameo, you have this home screen where it's got search. That's where you can search the database for a chemical. You have My Chemicals. So here you can build a list of chemicals, like a little favorites list or whatever. And then you have a reactivity profile. So we're going to go into the search first. So I'm just going to click search. And if you notice, it's got search by name. And then these are separate boxes. So not like Wiser where it's one box, but separate. If you got a CAS number, you come down here and search for CAS number. If you have a UN or NA, you click in this box. So personally, if I, don't want to worry about spelling something correctly, because I do struggle with that with some chemicals, an ID number is pretty handy. But I do know how to spell chlorine. And so what I want to show you here is when you use a chemical name, and the same with an NA or ID number, what it's going to do is it's going to give you every chemical in the database with either that name or as part of its name, or in the case of the UN or NA, it's going to give you every chemical under that UN. So if you notice, I've got chlorine. That was my first hit because it's most applicable to what I punched in for a search. But then it starts to get into chlorine derivatives. So here's chlorine dioxide, chlorine monoxide, and so on and so forth. So if you're looking for, iodine monochloride, just typing chlorine in, you can find it that way. So we're going to click on chlorine. I can also just click on the view data sheet and it'll bring up the same thing. Or that other button was where I could add it to my chemicals. So when you first look at it, it's got the name of the chemical up here. It's got all of the applicable DOT hazard classes up here in label version. So it's a class 2, it's a class 5.1, it's class 8. So just a little quick reference there. And you also have add to my chemicals. So there's another chance to add it to your favorites list. The other button up here is print friendly version. This does not print very well because it's really made to be an interface with all sorts of hyperlinks and all that good stuff. But if you want to print this data out and hand it to a technician, you can hit print friendly page and it'll reformat it and you can send it to the printer. So the first section here, we do have this menu up here. This menu is hyperlinked to this front page. So if I click on something, it'll just take me down the page to it. So I typically don't use it all that much because I need to scroll, right? So the first thing I want to see anyway is the chemical identifiers to make sure I have the right chemical. And so right away, it gives you the CAS number. It also gives you the UN or NA number. Now, this is hypertext. We'll come back to that, but there is a hyperlink there. It's got the DOT hazard label. So again, these are labels up here, but in DOT's world, if there's a chemical that meets more than one hazard class, you have to put all applicable labels on. Now that does not work that way for placarding, but for labels it does. So they're telling you all three of these labels are applicable. Over here, you've got a USCG CRIS code. So the CRIS manual, U.S. Coast Guard, right? CRIS stands for Chemical Hazard and Reactivity Information Sheet. And again, we have a hyperlink there. I'm going to show you that as well here in a little bit, but that's another chemical database. We also have the NIOSH Pocket Guide. So I will click this one right now just to get it out of the way. But you can see chlorine is hypertext. If I click it, what it's going to do is bring up the NIOSH chemical guidebook page for chlorine. So it's just a little quick link. The reason I wanted to get it out of the way, and really the reason I don't use it, is because you've got to have internet connectivity to open that. And so if you are not on a hotspot or don't have Wi-Fi, you can't get to it. And again, I just usually have my NIOSH book sitting on the table next to me or in my lap or whatever. Here is another one too, the International Chem Safety Card. And again, I'll click on this one to get it out of the way as well, because you can see it opened up in an Internet Explorer. This is the World Health Organization's chemical database, I guess you could say, on chlorine. And again, the reason I don't use this a lot is because I have to have connectivity. If I'm using CAMEO offline, that hyperlink won't take me anywhere. So unfortunately, NIOSH and the World Health Organization's chem cards do not download with the CAMEO suite, but the CRIS code does. So when you download CAMEO, you'll automatically get CRIS, and CRIS will work online or offline. So just to kind of satisfy your curiosity, I'll click on it, and we'll look at the CRIS here in a bit, but this is basically the Coast Guard's information sheet, if you will, on chlorine. So it's another chemical database. When we talk about chemical databases, if we can, we try to use 3 references. It's a good habit to get into. I have seen mistakes in the information where 2 chemical references aren't jiving with each other. And so the third is the one that steals the vote, if you will. And it sometimes, well, most of the time, what I would tell you is it was like an odd number. You know, it was pretty easy to understand it was a typo or something like that. Or maybe they got the decimal place off. But if you're only looking at 2 databases and they have conflicting information, you don't know which one's right. So that's where the third one comes in. And so I showed you guys Wiser. I showed you NIOSH, and I always say I have my NIOSH book with me. If I'm looking at CAMEO, those are 3 chemical databases, right? Now, if you're wondering about the ERG is not a chemical database. The ERG is a guidebook. It's a response guidebook. It basically has protocol on how to respond to that chemical. It's not going to tell us things like vapor pressure, specific gravity, molecular weight, things like that. So to be a database, you got to be able to give me those numbers. Well, the International Chem Safety Card gives us those numbers. NIOSH gives us those numbers. Wiser gives us those numbers. CAMEO and CRIS as well. So I have pretty much 5 databases at my fingertips. And that's a lot of information, right? So pretty cool. And like I said, we'll get back to CRIS. Now, before I move on, I do want to show you this hypertext. So what do you think is going to happen here when you click on the ID number? Yep. There's our ERG. Now, if it's a green highlighted chemical, it's going to give you the green highlighted stuff first. If I want to see the actual guidebook for this, I have to click over here where it says Response Guide 124, and bam, there I have the ERG at my fingertips. So I'm going to go back here and get back into this. So after this preliminary information, I've got an NFPA 704, so it's going to tell me what the diamond is. Again, I talked about that with Wiser, but you may be able to match this up with a fixed tank or a fixed facility or something like that. It's got the general description of the chemical, so it's going to talk about color, you know, just basic high-level information. I do like this, though, here. This is signs and symptoms, so it's giving you the rate of onset. So if someone was exposed to chlorine, we should see effects immediately to hours. Well, that's still kind of general, but what it doesn't say is days. So, you know, this may prompt us to hold someone at the hospital for monitoring until we felt like we were past the hours. And then persistence of those signs and symptoms, again, minutes to hours. So how long is this going to last? This is pretty handy here too, the odor threshold. So if people were saying, hey, no, we never smelled chlorine. Well, maybe that means they were below that 3.5 threshold. It gives you hazards here next. So it's going to give you the reactivity hazards. It's going to give you air and water reactions, fire hazards, health hazards. Here's its reactivity profile. So it's going to tell you everything on God's green earth, what can react to chemical or this chemical. It tells you what reactivity group it belongs to. So it's an oxidizing agent. You know, a lot of people don't know this, but chlorine actually oxidizes fire more efficiently than oxygen. So it's a very strong oxidizer. And then, of course, it's in column 7 of the periodic table of elements. It's one of those halogenated agents. This is pretty handy here as well. It's got potentially incompatible absorbance, because one of our go-to tactics is to absorb, right? Now, chlorine is a gas, so you might not really have the ability to absorb it, but if you had it mixed with water, we could try an absorption tactic. Well, here's the stuff that we may not want to utilize for absorbing up that water, because we could have a reaction. The response recommendation section, this is, in my mind, it's lacking. They really kind of just took what was in the ERG and reformatted it a little bit. It doesn't tell you, you know, a lot. It's not going to tell you to put a chlorine C kit on a rail car or anything like that. It's got a protective clothing section, so this is going to be just very general. But we do get into something very handy right here, and that is DuPont Tychem suit fabrics permeation data. So if you're using DuPont suits, you do not have to go in and see if your suits are compatible with their database. You can come right here to CAMEO. We used to rely on this a lot when we used all DuPont suits on the hazmat team, but unfortunately, well, fortunately for us, because they're a better suit, but we went to Kapler, and they are not publishing Kapler's information. Maybe they will in the future, maybe get St. Gobain in here or something like that. But right now it's just DuPont. But it's, you know, one-stop shopping if you're running a DuPont suit. And then they get into first aid information, right? So they're going to tell you what to do if someone was exposed to this. The next section, this is the nerdy section we love. This is the chemical and physical properties. So it's going to tell us how chlorine behaves. And I would tell you this is probably the section that I'm bouncing off of different chemical databases. You can see, for example, right here, the vapor pressure. They give it to you at 86 degrees Fahrenheit. Well, standard vapor pressure is measured at 68 degrees Fahrenheit. And we all know that chemicals, you know, vapor pressure is a curve. So a lot can happen in 10 degrees with certain chemicals. So, hey, if I don't like this vapor pressure because I'm way closer to 68 than I am 86, I can go into another chemical database and see if I can find a more relevant vapor pressure. So the AEGLs listed here. So a lot of times in hazmat, what we talk about is doses for the worker. So we go into NIOSH and we look at the recommended exposure levels, or we're in OSHA and we're looking at the PLs, the permissible exposure limits. What we don't really have is a lot of information that says, hey, what happens to the unprotected person? You know, if you look at a lot of time-weighted averages, you know, if you inhale over the time-weighted average, it's really not going to do any damage to you. Maybe slight effects, but typically there's no effects. So, you know, it's an exposure according to, hey, I breathe more than this number says I should. But what we really want is like, hey, what is this doing to people? You know, chlorine's a very noxious gas. It's going to make them cough. It's going to make them want to move. At a higher concentration, you know, it's going to take them down. Well, that's where these AEGLs come in. And they're pretty cool from the standpoint that we actually have data now that can tell us, hey, at this concentration, this is what you can expect with the public. So to go through these really quick, you have AEGL1, AEGL2, and AEGL3. And basically, to explain these, is AEGL1, those are walking wounded from a triage standpoint. At that concentration or less, and then of course they have a time over here, because we all know that the dose response relationship is the dose times the time that they were exposed. So, if they're 0.5 or less, hey, it's all right, no big deal. At 0.5, we can expect signs and symptoms, but there should be no loss of permanent health due to these victims. That doesn't happen until AEGL2. So when you hit AEGL2, now we're looking at permanent health effects. Possibly, maybe they're non-ambulatory because they can't self-rescue or move on their own. And then there's AEGL3, which really means they're going to reach an IDLH environment at that dose at that time. So you can expect to have a fatal dose at 50 part per million of chlorine for 10 minutes. So this really gives us the ability to hey, where are we going to concentrate our efforts? Well, that's the AEGLs. And maybe, these other ones, the emergency response planning guidelines and protective action criteria, we can go into these too. I really look at the AEGLs because, like I said, they give us time, and that's kind of cool. If we know a vapor cloud's going to come through an area, but it'll take a while to dissipate, like up to an hour, well, hey, this is usable information. Where the ERPGs and the packs, they don't give us time associated with them. So, this might be really good to talk about in a separate class and go over all these doses. The regulatory information, it's going to give you, CERCLA quantities, RCRA codes, if it's waste, all this good stuff. Not a lot of usable information there for the hazmat technician. And then the last portion there is alternate chemical names. So that is the front page of CAMEO. So just to wrap this portion up, we'll look at the CRIS real quick. Oops, I apologize. That was the ERG. I got to open my CRIS back up. And so when you look at CRIS, you open it up. Now the information's kind of arranged a little differently. Up top, we've got just some general response information. They're going to give you some identification features like irritating bleach-like choking odor. They have fire information where they say, hey, it's not flammable, but poisonous gases can be produced in fires. They have some exposure information, what it's going to do to you there. Of course, it's the Coast Guard, so they're going to give water pollution information. And again, that's really not too much data we're looking for. But when we get down here, the chemical designations, here we start getting into some of our nerdy information, if you will. We got the chemical formula, so Cl2, diatomic molecule of chlorine. We've got the DOT ID number. We got the CAS number. We got the ERG guide number listed there. When you get into the health hazards, this is where it's going to give you the worker doses, like the OSHA PEL. It also gives you the NIOSH IDLH value, and it's also giving you the ACGIH TLVs. So these are all good numbers to protect us and know when we should be getting into certain equipment. Up here on the right-hand top side, you got fire hazards. So if this was a flammable, this is where we could get the flash point and all that good stuff. Section 7 here is the shipping information. 8, again, is just more identification stuff, really. They're talking about 49 CFR, so that's DOT, what hazard class does this ship as? Well, it ships as a 2.3. It's got the NFPA placard there again. Section 5 is the chemical reactivity. It's got water pollution. And then Section 9, again, this is another one we go to for numbers because it's going to have like the molecular weight and boiling point and things like that. So that is the CRIS manual. It's another database. It's another tool in the toolbox. You can see they haven't updated this information in quite a while. I know for a while they discontinued the CRIS, but then it came back and they decided to upkeep it. So I don't see chlorine changing too much over the years, but it's been a while since it's seen an update. Okay, so what I'd like to show you now is the chemical reactivity. So there's probably more than one way to do this, but this is what I do, is I go in and I find my chemicals. So we'll go back to chlorine. And I search for chlorine, and I need to add it to my chemicals. So once I click add to my chemicals, you should see it. Yep, right there. So one chemical added. If I want to view my chemicals at this point, I can click on that, but I'm going to add another chemical here real quick. And we'll mix our chlorine with ammonia, and hopefully everyone knows to never do that. That's super dangerous, and maybe we'll find out why. So here I got anhydrous ammonia, so I'm going to add that to my chemicals. And now that I have both of those chemicals in there, I go to view my chemicals. And it tells me in here, you know, hey, this is your two chemicals. You know, if you want to look at the data sheets, you can. But the second bullet point, it says, consider the reactivity predictions if these substances were mixed together by going to the reactivity page. And that's hypertext there. So if I hit the reactivity page, what it does is it gives me a chart. So it's got ammonia on this side. It's got chlorine up here. And when you match the two up, it's telling me all the bad things that can happen. It obviously says they're incompatible, and it's got a little red box there like, hey, don't do this. And it's going to tell me it could be corrosive, explosive, generates gas, generates heat, intense or explosive reaction, and of course it's toxic. If you scroll down a little bit, it's just got a little more information. You got some documentation that you can print out there, and it talks about all the reactions. I believe, yeah, I was going to say, if you click on this, you get the same thing. Essentially, it jumps you down here, and then you can go to documentation. Going back real quick here, if I can back out of this, I want to show you one other thing. So let's say I just have chlorine, but it was a 1-ton cylinder, rolled off a truck and went in a stream. And so I'm going to remove by clicking on the little remove button. I'm going to get rid of ammonia, and I'm just going to hit add water. And it's going to put water in a drop-down list just like it would a chemical. And then if I hit reactivity, it'll take me back to the same chart. It's got water, it's got chlorine, and it's going to tell me the reactive mixtures here. And of course, you know, it's all death and destruction because we never put chlorine in swimming pools or, you know, water at all, right? But of course, this is the worst case scenario, and this is what could happen. So that's the chemical reactivity. It's not quite as user-friendly as the one in Wiser. I think the one in Wiser is a lot more user-friendly. But again, tool in the toolbox. If you run a reaction in Wiser, you can run it here in CAMEO and just see if you got the same thing and compare the two. So that is CAMEO Chemicals. Hopefully you guys get in here and play around. And again, as always, my disclaimer, if you learned something that I didn't tell you, please let me know, because I am by far from a power user. All right, thank you.